In the last video, we discussed how you could determine the enthalpy of a reaction by examining the bond energy, the energy required to break the bonds in the reactants compared to the energy released when bonds form in the products. That, along with our activation energy graphs, or potential energy graphs, are all well and good when we're trying to discuss theoretically, but it doesn't help us when we're actually doing an experiment in the lab. And so to do the experiment in the lab, we use something called calorimetry. In calorimetry, what we're going to do is we are going to measure the amount of heat released by one system. So energy is released by one system. So let's call it system A. And we measure this by determining how much energy is gained by system B, which in our case is going to be water. So the energy will transfer due to the law of conservation of energy. The amount of energy lost from system A will equal the amount of energy gained by the water. When we do this setup, we usually use a pop can that has an amount of water in it. Now, it's important that you choose the proper amount of water. You need enough water that you can measure the temperature difference using a thermometer, but you don't want so much water that the amount of energy needed to change the temperature would be too large. Usually we're working with small samples here. And you also need to use a large enough sample that the water's not going to boil, because once the water boils, it becomes a different story. We now need to use our heat of vaporization, and we don't want to get to that point. So, in the example we did the other day with the popcorn, I gave you an amount of water that we were going to use when we took the popcorn and ignited it. And so in order to do this experiment, to do the calculations, we're going to use our good old friend Q equals MC delta T. Now, in the lab that I gave you the other day, I gave you the mass, the initial mass of the amount of popcorn that we had. I gave you the final mass of the popcorn that we had. I gave you the initial mass of the water. Oops. And I gave you the final mass of the water. No, I didn't. I lied to you, because lying is fun. I just gave you the mass of the water. You had 3 masses. I'm going to make up some numbers here, so these numbers will not be the same as the ones we did the other day, but it'll be enough to get the point across. And so on this one, I'm going to have that the amount of water used was 12 grams. I'm going to say that my initial amount of popcorn was 20 grams and my final mass of popcorn was 10 grams, so that my change in mass of popcorn is going to be 10 grams. We're just going to keep some easy numbers here. Now, we also need to measure the temperature of the water before it occurred, and so I'm going to say that my initial temperature of the water is, let's say, a little bit colder than room temperature. So room temperature would be 25 degrees Celsius, so let's say that it's 17 degrees Celsius. And then I'm going to have my final temperature. And again, while these numbers might be a little ridiculous, we're going to just try to keep things easy and let's do 22 degrees Celsius, because then that means that my change in temperature is going to be 5 degrees Celsius. And so now with this information, we can see why I can't measure the heat that is released from the popcorn. I don't have enough information. In order to do MC delta T, I need my mass, which I do have the mass of the popcorn. I need the specific heat. I don't know the specific heat of popcorn. I do know the specific heat of water, however. It's a constant, and this is a constant that has always and will continue to be given to you. but it's 4.184 joules, grams, degrees Celsius. So I know the C of water. I don't know the specific the heat capacity of popcorn. And I need a change in temperature, and I have the change in temperature of water, but I don't have the change of temperature of popcorn. So I'm going to go ahead and determine the change in heat of the water. And so by doing this, I have my mass, which is 12 grams. I have my C, which is 4.184 joules, grams, degrees Celsius. And I have my change in temperature, which was 5 degrees Celsius. And so I'm going to plug that into my calculator. The energy change, the temperature change is positive. That makes sense because energy was entering the system. And so when I do that, I get that the Q of H2O in this example is 251.04 joules. The reason why it's joules is because my grams cancel out, my Celsius cancels out, and so I'm left with joules. Now, since I asked you to determine the enthalpy of the reaction, I'm going to convert these joules into kilojoules. Even though this isn't a large number, I know that my enthalpy is kilojoules per mole. And so, if I convert this to kilojoules, there's 1,000 joules in 1 kilojoule, and so the amount of kilojoules that entered my water are 0.251 kilojoules. That's the amount that entered my water. If I wanted to know the amount of energy that exited my popcorn, it's simply going to be the same number, but with a negative because it exited the popcorn and entered the water. So I need to figure out kilojoules per mole. I now know the kilojoules that were made that came from my popcorn. However, I don't know the moles. But what I do know is that my popcorn had a mass of 12 grams. And so with this, I need to calculate the molar mass of my popcorn so that I can determine the amount of moles of popcorn. And in the warm-up from the other day, I tell you, as I'm trying to look for this real quick, I tell you that the formula for popcorn, it's mostly starch. And so the formula for popcorn is C18, H30, O15. And when you calculate that molar mass, that gives you a molar mass of 486.48 grams per mole. And so I need to convert my grams to moles. So I have 12 grams. Grams goes on bottom, so 486.48 grams in 1 mole of popcorn or starch. And so this gives me, sorry, I was just checking my math there for a second. This gives me 0.025 moles of popcorn. My grams cancel out, so I end up with moles. And so now I need to determine the enthalpy. And the enthalpy, as we said, was kilojoules per mole. And so if I want to know the enthalpy of the popcorn, I'm going to use the kilojoules of the popcorn. And I'm going to divide it by the moles of popcorn. And I get 10.04 kilojoules per mole of popcorn. This is negative because this is the energy that left the popcorn, the enthalpy of the popcorn. If I want to know the enthalpy of the reaction, so if the reaction is me consuming the popcorn, then consuming the popcorn means that I'm taking in the energy of the popcorn. And so then in that case, I would use a positive energy. So if I wanted to know the energy gained by consuming this amount of popcorn, then it's going to be a positive 10.04 kilojoules per mole. So this is gained by consuming popcorn, and this is released by the popcorn. And that's how you determine enthalpy by using calorimetry.